Often in statistics, we're interested in working with what is called bivariate data, or data that comes in kind of an XY pair, and we want to know if there's a relationship between X and Y. The way we measure a relationship between X and Y is this thing called the correlation coefficient. And the statistic we're going to calculate to measure that strength between the two variables is the letter R, which is the correlation coefficient. It is a measurement of how close to a straight line the bivariate, that just means X and Y, bi meaning two variables, bivariate, the bivariate data is. So if I think about some scatter plots, you might remember from your high school math classes, a scatter plot is a graph of X and Y dots. We'll make 3 scatter plots here so that we can compare them. In this first scatter plot, we're going to have some dots going up like this. In the second scatter plot, we're going to spread them out a little bit more. And in the third scatter plot, they're going to kind of be all over the place. If we were to try and draw a line through the dots as best as possible, this first one draws a pretty good line that goes right through the dots. Because those dots are really close to the line, we want to say it has a very strong relationship. And so for our R, that measurement of how close to a straight line it is, how strong that relationship is, it's going to be pretty darn close to 1. Maybe this is going to be 0.9997 or something like that. The closer to 1 it is, it means that we have a stronger relationship. Versus the second graph, you see the dots kind of go in this direction of a straight line, but they're not really close to the straight line. There's a little bit of space in it, so the relationship's not as strong, it's not as tight. It doesn't make a perfect straight line, so you're going to see a smaller r, maybe 0.6123. And then this last one, the dots really don't make a straight line at all. The best we can do is draw a horizontal line through the middle, but that's not even a really good relationship. That one's going to have a really small line to show that there is almost no relationship happening between the x and the y variables there. So that's kind of what we're talking about when we're talking about how close to a straight line the bivariate data is. On the scatter plot, the dots close to a straight line is an R, a measurement, a strength of 1, or close to 1. And way off from the line, making no pattern, the R is going to get closer to 0. So let's summarize that. R measures the strength of the relationship between two variables. And R is going to come in sets of 1/5 or 0.2. If R is between 0 to 0.2, we say it is a very weak relationship. If it's between 0.2 and 0.4, we're going to say that's a weak relationship. If it's between 0.4 and 0.6, we're going to say that's a moderate relationship, kind of in the middle. But when we start getting above 0.6, maybe 0.6 to 0.8, then we start talking about it being a strong relationship. And then finally, if it is between 0.8 and 1.0, that's when we'll start talking about a very strong relationship. And we kind of saw that in the pictures up above. In the pictures, that first picture, those dots are really close to the line. That's a very strong relationship. The middle one, it kind of looks like it's following a line, so maybe it's strong, high end of moderate. And the last one, very weak, no relationship. Those dots are just all over the place. The other thing to understand about R is R can be positive or negative. The sign of R also tells us something about the relationship. If R is positive, a positive R means we have a positive relationship. If one variable goes up, the other goes up as well, positive. They're both going in the same direction. In other words, we're going to see dots going kind of like the examples we saw up above. As the x gets larger, the y gets larger, we're going in the upward trending direction. That's a positive r. A good example of something that's got a positive relationship is if we're looking at a child that's growing. There's probably a relationship between the height of the child and the weight of the child. Whereas the child gets taller, the weight probably increases. Same with the weight. As the weight increases, the height is probably also increasing in general for children as they're growing. Now, sometimes the sign of r is negative. That means we've got a negative relationship. In other words, if one variable goes up, the other variable goes down. They're going opposite directions. So in this case, if the x is small, the y is going to be large. And then as the x gets bigger, the y's will also get smaller. They're going in opposite directions, and you see that negative slope, that negative relationship, meaning it goes down. An example of something with a negative relationship might be comparing your absences from class and your grade in the class. And it might make sense that as the absences go up, the grade is going to go down. If the absences go down, the grade is probably going to go up. They're going in opposite directions. We're going to have a negative sign on r. So we've got two things we look at r. The number itself that tells us how strong it is, and then the sign, which tells us the direction the variables are going. So you could have a negative strong relationship. You could have a positive moderate relationship. We can combine these together to interpret r, which is the strength of that correlation coefficient. How strong is the relationship between the two variables, x and y?